All right, so in this module, we're going to talk about the concept of degree of polymerization and work through an example of that. So degree of polymerization is the average number of repeat units that is in a sample per chain. So it's basically connected to what we saw with the average molecular weight, but instead of doing that in terms of weight, it gives us the average number of repeat units we have per chain. So again, for this one, this is polyethylene, as you might recall. So we have carbon, carbon, hydrogen, hydrogen. And so basically, degree of polymerization, or DP, as it's given up here, is how many of these repeat units are in a given chain. So it's another way of determining how long or heavy the chain is. And so we can calculate degree of polymerization, or DP, by taking the number averaged molecular weight and then dividing by the average molecular weight of the repeat unit. And the reason we have the bar here and say average is that if we're dealing with the copolymer, then the repeat unit will not have the same molecular weight as another repeat unit, right? So if this is just a homopolymer, then there's only one molecular weight for the repeat unit. It's easy, you just replace that. But if you have a copolymer that has more than one, then we would have to average the molecular weight. And so we can do that by looking at the molecular weight of the repeat unit and then the fraction of the chain, and then summing up that as well. And so again, we're looking at how many of these repeat units. So if we just kind of count through this one, we see that we've got 1, 2, 3, 4, 5, 6. So the degree of polymerization is 6 on this chain. And so if that's the average chain, then the number would be 6. But again, all samples have a distribution. And so they're not all going to have exactly 6. For an average sample, some will be lower, some will be higher, as you're aware. Okay, so that's what degree of polymerization is, and the reason we want to talk about that and the average molecular weight is because both of these properties, both of these characteristics are impact the properties that a polymer has. So the physical properties of polymer are very sensitive to DP, and in terms of various properties, so let's take a look at melting temperature, for example. This has kind of an asymptotic relationship in that very low degrees of polymerization tend to have a very low melting point. So you can think of this as the same example with polyethylene. Polyethylene, when it was very, very short, like methane, right, was a gas. When it was in the intermediate range, it was kind of a wax, a paraffin wax, candle wax. And then when it was much larger, it was a solid. The same thing here. We see that if we're only 100 grams per mole, or we only have a few repeat units, then it tends to be a liquid. And then kind of waxy if you're up in 1,000 grams per mole. And then if you're in 10,000 or more, it tends to be a solid polymer. And so the properties tend to kind of level out as you go up. But again, there can be quite distinct changes of the melting temperature, but also a lot of other properties with increasing degree of polymerization or increasing molecular weight. So some other ones that are affected by degree of polymerization. So increasing degree of polymerization can cause an increase in tensile strength, creep resistance, impact toughness, and wear resistance. So again, this the longer and longer the chain it is can kind of improve a lot of these mechanical properties of a polymer. All right, so let's look at an example problem with the degree of polymerization. And this is going to use the data that we had from the previous example in the last module. So given that we know the number average molecular weight and the weight average molecular weight, and we know that this polymer now, we weren't given the information before, but let's say that the polymer is polyvinyl chloride, or PVC. what I want you to do is see if you can calculate the degree of polymerization, assuming that we have PVC and we're given the values here from the previous problem. So see if you can calculate degree of polymerization and go do that on the quiz, come back, and we will see what you get. All right, so let's take a look at this problem and calculating degree of polymerization. All right, so we know degree of polymerization is the number averaged molecular weight. So we're going to use that number and we're going to divide it by the molecular weight of the repeat unit. So this is PVC. So this one you had to know what the repeat structure looks like. And so to calculate the molecular weight there, we're going to have 2 carbons. So 2 of these carbons, and the weight of carbon, atomic weight, is 12.01. We have 3 hydrogens, so we're going to have 3 times 1.02. So obviously they're very close to 2 and 1, as you're aware. I just tried to add a little bit more there. And then we have 1 chlorine, which is 35.45. You can find this on the periodic table, information in your textbook. And so if you add all that, the molecular weight of the repeat structure, so just this one repeat structure, is 62.5 grams per mole. So we need that for the denominator. We have this from the previous question. And so if we divide those, 21,150 grams per mole divided by the 62.5 for the repeat structure, we get the average degree of polymerization, the average number of repeat units is going to be 338. So that's telling us for the average chain of PVC in this material, there's an average of 338 repeat units for that chain in this distribution. Obviously, there's some with more, some with less, but this is the average. So that's what this DP, or degree of polymerization, gives us for polymers.